We're live. We're going to be solving problems using combinations. You might remember me from such films as Solving Problems Using Permutations. Sorry, that's a Troy McClure outtake. So we're going to look at a few of the problem-solving strategies that involve combinations. First of all, we're going to look at counting subsets of things. And so we've got multiple possibilities. We need to count each subset and add them all together. We're also going to look at the indirect method by which we can avoid counting subsets. And then next, we are going to look at multiple subsets where we have to choose our items first, and then we have to decide how we're going to arrange them. Okay, so here comes the first problem. So this is a counting subsets problem that we are then going to look at the indirect method of counting them. So I have a deck of 4 aces here. And basically, I'm going to deal them out such that you might get 1 or 2 or possibly 3 or 4 aces, okay? And you don't know how many you're going to get. Notice there's only one possibility missing, and that is dealing out no cards. So we're going to deal with that when we get to the indirect method. So how many ways can I deal between 1 and 4 cards? Well, if I only deal out 1, I've got 4 cards, and I'm going to choose one of them. So I've looked after that situation. But I might get 2 cards. So I have 4 cards to choose from, and I'm going to pick 2 of them. The other option is 4, choose 3. And finally, the last one, I have 4 cards, and I can choose all 4 of them. So I've counted all of the possible subsets that are outcomes in this situation. Okay, so I think I can do this. 4 choose 1 is 4. And 4 choose 2, that's 4 times 3, which is 12, divided by 2 times 1, which is 6. Plus 4 choose 3, which is 4 again, plus 1. And so there are 15 possible ways that I can deal between 1 and 4 cards out of all of those aces. Okay, let's do this indirectly, because there's only one case that's possibly missing from this, and that is the case where we get no cards. So let's just try and figure out how many total possible ways I can deal out all of the cards. Okay, kind of a tricky bit here, but just stay with me. 2 possibilities for the ace of clubs. It could be included in my hand, or it might not be included in my hand. So for the ace of clubs, do I draw the little clubby thing here? Sure enough, there it is. Ace of clubs, 2 possibilities. Either it's in my hand or it's not. Okay, ace of spades, which is maybe a little easier to draw. There we go. Once again, 2 possibilities. Either it's in my hand or it's not. Same thing with the other 2 aces, which I won't draw the symbols because I'm just a bad drawer. So in other words, total possibilities in this case is 2 to the exponent 4, or there are 16 possibilities. There's only one of those, not getting any cards, which isn't included in my problem. So this is 2 to the exponent 4, take away 1. And surprise, surprise, that's 15 cards, same as before. Okay, so we've looked at the method of counting subsets. We've looked at the indirect method where we count everything and take away the ones that we're not interested in. Now we're going to look at a different situation. And so this is where we have to choose from items. And then it also involves permutations because we're worried about the arrangements. Okay, we're going to go with our card example here. Just like we did before, have a deck of 4 aces and all the face cards. Okay, so it's that euchre thing, no ace, no face, no trump. Maybe we want to find out something about that. So we've got 4 aces and all the face cards. There are 12 face cards altogether. Okay. So how many orders? So this is going to involve permutations eventually. can I be dealt? 2 aces and 3 faces. Okay. So this involves combinations, and then we need to consider the permutations. So here we go. There are 4, so choose 2 ways that I can choose my aces. Each of those can be combined with all the ways that I choose my face cards. So there are 12 face cards, and I have to choose 3 of them to make 5. Okay, those are all the possibilities of the combinations of 2 aces and 3 faces. If order matters, all I really need to do now is multiply that by the number of permutations of the 5 cards. And so I multiply that by 5 factorial. Okay, so this is the example where you choose them first, and then you multiply by the number of permutations of those 5 cards that have been chosen. And it's another useful way of solving combination problems. That's it.